In this example, we will do some simple operations with accessing elements of matrices, and so we have a specific matrix to be defined, and then we should provide commands that will do some picking and creating other new matrices. So let's clear our space, and we start from defining that matrix which is given. 2797. Then in another row 3156, and one more 8125. Fine. Okay, so we have our matrix A. Now the first point says assign the even indexed columns of A to an array called B. Even indexed columns. If our matrix is arranged like this, remember index means location. In the indices of rows are oriented like this, indices of columns are oriented like this. And now we say even indexed columns, so it means that we would like column with index 2, which are even numbers. 4, if there were more columns, there would be probably 6, 8, and so on. So in our case, we basically need columns 2 and 4 to be picked and assigned to an array called B. So the easiest way is we say we take matrix A. There is no limitation on rows, so I pick all of them using the column operator, but the columns were supposed to be just the second and fourth. Now this will work fine for this specific case. So if our A is really this size and we really want just second and fourth, or even this array is this, but we want all even indexed, it's okay. But if our matrix changes, the A matrix, then it means we would have to change this piece of code here. And it is smart to write your code in such a way that if only the input, the initial values of your variables in the beginning change, the entire code adapts so that you don't have to start modifying hundreds of lines just because you maybe added one column or two to your matrix. So it is smart to write this a bit differently. If the task says all even indexed columns, so what it means, even numbers start from 2 and go on as far as it takes. So I will say that from second column, I want to take step 2 and go until the last column of my matrix. So now, however big my A is, it can have 1,000,000 columns, but I'm sure that my B will contain all even indexed columns from it. Just because I wrote the code so that you don't need to know the size of your matrix. So this is a much smarter way to write the code. Now point B says assign the odd indexed rows to an array called C. So it's very similar, but now we are not accessing columns, we are accessing rows. So in here, once again, even indexed, so now it means 1, 3, 5, 7, and so on. In a simple way, we can write like this. So I know my matrix has 3 rows, so odd index means first and third. But once again, if I want to be smart and I don't want to keep changing all my lines in case I change matrix A, so I will write it like this. I start from the first row because it's the first odd one, again take step 2 and go until the possibly last row. So this is how it would work. And for instance, it wouldn't matter if our A matrix, for instance, only had 1 or 2 rows. It would just mean that it takes the first one, and that since the step 2 goes beyond the size, it just ignores anything else. So there will be no problem with any error. Point C says convert A into a 4x3 array. Now it is 3x4. So we can either transpose it or reshape it. So I'll call it A1, will be A transposed, and A2 will be reshape A to 4x3. So once we have done it, you see that yes, the shape has changed to the one we desire, but the elements are organized differently. Because remember that reshape fills in the matrix. So let's bring the original one also. So A was like this. If we use transpose, what it means that this first row will become first column, and you can see that that's what is happening here. Then second row will become second column, and then third row, third column. But reshape was working differently. It takes those elements and it starts filling them up. So it picks them by column, first column, second, third, and it fills the columns also. So that's why here it takes from the original matrix 2, 3, 8. There's one more needed, so it picks 7. And then it takes 1, 1, 2 are missing to the second column, so it takes 9, 5, and then the remaining 2, 7, 6, 5. So the task didn't really specify how the values should be arranged, so in this case either one is okay. But depending on the possible purpose, if this was a more specific task with some practical application, that would be up to you to pick the right way to do it. Then compute the reciprocal, or in other words, inverse of each element of A. So now keyword each element, so it means we have to do the inverse element-wise, and that's very simple as well, because we know that for element-wise operations we have the dot operator. So I cannot just say 1 divided by A, but if I say it with a dot, so it means it will be 1 divided by each element of A 1 by 1. So the resulting inv A matrix will be equally sized as the original A, but it will have now inverse of every element. And finally compute the square root of each element of A. So for square root we do have ready function, which is sqrt, and if there is a ready mathematical function, then it is already adjusted to work on vectors and matrices, which means that we don't have to do any dots in here. Square root function does know that if it gets a matrix, it should just calculate square root of the respective elements. So when I run this, I get square roots of all the elements.